Hello everyone, welcome to join GDUFA Public Workshop. This is a sub-session to C, Artificial Intelligence and Machine Learning for Generic Drug Development and Assessment. In this presentation, I will talk about leveraging AI and machine learning to support regulatory efficiency and current progress. This presentation reflects the views of the author, should not be construed to represent FDA's views and policies. What's artificial intelligence, AI? According to John McCarthy, one of the founders of the discipline of AI, it's the science and the engineering of making intelligent machines, especially intelligent computer programs. Commonly speaking, machine learning is a subcategory of AI. The recent decades has witnessed the exponential growth of AI. The AI is transforming our daily life, such as ATM, smartphone, autopilot, chatbot, personalized recommendations. Given the prevalence of AI, we also see the opportunities of AI to facilitate generic drug development and regulatory assessment. The first aspect of AI can help is development of automation tools, such as for streamlining labor-intensive tasks. With automated process, we expect to see enhanced efficiency, improved consistency, and high-quality deliverables. The second aspect we see the benefit of using AI is to borrow recently developed advanced data analytical methods. Those technologies can be used for promoting business intelligence, like modeling, optimizing business process. The advanced quantitative analysis method can also be used for supporting regulatory assessment, for example, API sameness assessment. Given the time, this presentation will focus on development of automation tools. For our efforts on data analytical methods, reference were provided in the end of the slides. For development of automation tool, people usually aim to automate labor-intensive works so as to enhance efficiency, consistency, and quality. In order to accomplish this, there are several major challenges the development team has to face. The first one is data efficiency. Simply saying, do we have sufficient data, including amount and quality, to build up the AI models? The second one is pattern recognition, meaning, is there any pattern or standard route in current practice that AI models can be applied to realize automation? The third challenge is AI model selection. This one requires the development team has both enough domain knowledge and in-depth understanding of AI model candidates to achieve the best cost effectiveness. The last one is how to deal with unstructured data. For example, free text and untabulated data. This part often becomes the bottleneck for the whole AI project, which often has no routine to follow and requires a lot of creativity, but also bring a certain level of uncertainty for the project. Here, I would like to share some experience challenges from one of our ongoing projects. The ongoing efforts is a contract focusing on applying text analysis and machine learning to facilitate the PSG, which is a product-specific guidance development. The left side diagram displays a high-level thinking on this project. According to our analysis, to develop a regular PSG for immediately released product, a developer usually spends 50 or 60% effort time to conduct information retrieval from public and internal data sources, such as drug labeling and the new drug application review, and use 20 to 30% effort and time for information summarization. For example, generating summary paragraphs from a lengthy document. Based on all the collected information, the developer will draw conclusions and draw recommendations, and etc. Given the current advance in natural language processing, which is NLP model, the project team is working on streamlining the information retrieval and the information summary part. If finally succeed, a significant amount of time and effort will be saved for the PSG developer, so that more time and efforts can be invested on the human intelligence involved tasks. Meanwhile, the project team was and is facing a few challenges, including, first, evolving layouts of source documents, for example, drug labeling and the internal review documents. Second, need for information retrieval based on semantic understanding. Third, capturing information from unstructured data, for example, reviews, analysis, comments in review documents. And the last one, choosing a proper NLP model. For this project, one specific task is to extract paragraphs with ADME information from drug labeling. However, in some drug labeling, keyword searching doesn't work. This is an example of a semantic understanding-based information retrieval from drug labeling for food effect. The two labels as shown here contain no keyword for food effect paragraph. Although the word food appears in the paragraph, using keyword searching for food will lead to a high false positive rate. The NLP algorithm has been applied to implement semantic understanding-based information retrieval. We now are able to correctly label the paragraphs with food effect information in drug labeling. As progress of this project, the state-of-the-art bidirectional encoder representation from transformer, in short BERT, model was used for this NLP application. An NLP pipeline was developed to extract drug product information, for example, ADME information from drug labeling with minimal human intervention. A paper on this research has been published. To wrap up my presentation, I would like to stress AI technologies bring opportunities to advance development and regulatory assessment of generic drugs. And we also need your input and insight on how to take full advantage of this opportunity to facilitate generic drug development. So please join the following panel discussion to share your thoughts, ideas. With that, I conclude my presentation. Thank you.